All right, so let's do a quick little intro of the power of zero. And this isn't on your notes, and I don't want you to write this down. I just want you to kind of get an understanding of what we're really trying to do. So we should know that no matter what the number is, even if it's something crazy like 4,233,342, and we multiply that by zero, it's going to equal zero. So my question is, what is the x value that would make this first binomial, this first number, 0, if it's x minus 3? Just kind of think about it for a moment. X minus 3. What would x have to be to make that first part a 0? I know, it's too obvious. It's too easy, right? If x was 3, right? Then it would be 3 minus 3, so this would all become 0. So then 0 times this big, huge, ugly number would be equal to 0. So we've satisfied it. Let's try it again. And again, if it doesn't make sense, this will help. 235,923. We want to know an x value that would make this right here a 0. To today. Now, we kind of already looked at this. We've already seen that if we make this one here equal to 3, that makes this 0. And if we make this one here equal to -4, well, then that makes this end 0. So if I have a binomial that is like x minus 3 and x plus 4, that means my x values, my x values for this would be 3 and x would be -4. Because again, if I put 3 in for this, no matter what this is going to make 0, and 0 times that makes 0. But on the other hand, look at that, I have an eraser and a pen now. It's so nice. If I put -4 in here, I'm going to make this one 0, and 0 times whatever this is also makes a 0. Okay? So, first couple of questions from your notes today. We want to find all the solutions to find that would help us get the values of x that would make these equal to 0. Now, I've kind of set you up so you can do this without even, this extra work step. Like, think about what you would add x to 7. Think about what x would be if you added 7 and made a 0. But if that's not kind of coming to your mind, what we do is we set up two equations. So I break up the two binomials and set them both equal to 0. And this will allow me to solve for the x value that will make a 0. Obviously, if it's adding 7, we subtract 7. And so this is simply x equals -7. That's one of the numbers that would make this all equal to 0. Or we can add 2 to both sides over here and see that if x was 2, that would also make a 0. We are going to solve these just like we would normal two-step equations. We're going to subtract 4 on both sides. I guess that kind of looks like a paintbrush, right? 3x equaling -4. I divide by 3, and voila, x equals -4 over 3. And the factoring part of this is review, so you got to have those skills. When we have a trinomial where the a value is 1, we can instantly go to the x method. Okay? So I said we were going to review these, and we are. Now we want to try to add to the b term and multiply to the c term. So we're adding to +4, but multiplying to -12. Okay. Now, we're going to want to make a factor list for 12. So over here, 1 times 12, 2 times 6, 3 times 4, 4 times 3. I'm repeating myself, and I will stop. So we're going to go 2 and 6, and then it's all about the signs. When we multiplied, we get a negative. So the numbers have different signs, one positive, one negative. And when we add them, it's positive. So let's go positive 6, negative 2. And now we go into two binomials. Check out this one. We want to break up that x squared into x and x. And then it's just minus 2 and plus 6. Now, where we would have stopped, after factoring last time, we have this set equal to 0. This is obviously a part of our process. So, I set this equal to 0. Now that it's factored, and I write two simple equations. X minus 2 equals 0. X plus 6 equals 0. And it doesn't take much to realize that if I add 2 to both sides, one of those x values is 2. I subtract 6 on both sides, and the other one is negative 6. All right, well, I hope we're ready to move on. And like I said, we're going to review all the ways that we factored. So that's factoring a trinomial. Next up is just a binomial. So how did we factor those? Well, this is the type where we had to label it the GCF, and we rewrote it as the distributive property. And again, these are equal to 0. So let's think of a number and or variable that is in both 2x squared and 14x. Well, 2 is the biggest number that can go into 2, so 2 goes into 14, yes. 2x is there, 1x there. They both have an x in common, so our GCF is 2x. Distributing is multiplying, so I want to undo that with some division. And that's going to lead me to simply x here, because 2 divided by 2 is 1. 2 over 1 makes just the 1x left. 14 divided by 2 is 7. X over x does cancel out. So that is what goes in the parentheses. There you have it. So there's factoring using the GCF method. A lot of people had success with that. Now that it's equal to 0, let's set this up so that 2x is equal to 0 and x minus 7 is equal to 0. Again, I take the two parts of this and set it equal to 0. Now, simply solve for x like you're solving any old equation. 0 divided by 2, still 0. And add 7 here, add 7 here. X is equal to 7. Factor. Remember, if we have x squared and 25 and they're both the difference of two perfect squares, we can rewrite it as two binomials. All right? And so obviously, if the area of a square is x squared, then all of the sides are x. So x times x, one side times another, can be broken up. And then 25, think about it. If it's 25 for an area, each side has a length of 5. So hopefully that looks familiar. And now what's different about these? One positive, one negative. So a positive 5 with a negative 5. And now that you've gotten it broken up into two binomials, we write this as two equations. X plus 5 equaling 0, x minus 5 equaling 0. And again, are you looking kind of for a shortcut? Do you know what this x is? Because when we add 5 to it, it makes 0. I think you're thinking about negative 5, right? And over here, do you already know what x is? Something minus 5 equals 0? Yeah, it's just positive 5, right? So there you have it, the two x values that would make either one of those a 0 value. And now I've only got one more, but I've saved the best for last. The factoring like we did last class. So if you had a little trouble with that homework assignment, if it didn't quite make sense to you, we had some trouble with office hours yesterday, here's a chance to ask me questions about the process that we'll do one more time live with you. One thing you're going to probably want to start with is labeling these numbers, the A, the B, and the C. And so they're always in alphabetical order when that's in descending order, okay? Exponent of 2, 1, and then no exponent. So what we start with is multiplying the A and the C term. And so you multiply 2 times negative 12. And 2 times negative 12 is negative 24. All right? Are coming up with the factors of a number difficult for you? Is that giving you trouble? Well, let me show you that shortcut again. go ahead, pull up your calculator and enter the number 24 where you see y equals, and then divide that by x. So if you do the number that you're trying to factor divided by x and go second graph, it pulls up the table and voila, it gives you all the factors: 1 and 24, 2 and 12, 3 and 8, 4 and 6. So if your math facts aren't that great, your calculator can certainly be a big help. 1 and 24, 2 and 12, 3 and 8, 4 and 6. Now, we are trying to find the pair that adds to this b term. So the pair that would make 5. 1 and 24, not going to do it. 2 and 12, not going to do it. 4 and 6, sorry, you're out too. 3 and 8. Now it's got to be positive 5, but negative 24. So signs are different. Let's go negative 3, positive 8. So I'm just going to rewrite this. Negative 3x plus 8x. And I'm just going to let you think about that for a moment. I needed to break this up from 3 to 4. Okay? I had to get to 4 terms. So I rewrote positive 5. Now, the 2x squared comes down, and the minus 12 is still there. Okay? So remember, this is like the process where we combined like terms to get to here, but instead we're trying to go backwards. At this point, we want to group these. So let's group them into 2 binomials. So here and here, here and here. Now that I've got it grouped, I want to find the greatest common factor for each one of these binomials. So I need a GCF. I'm going to get really colorful today now that I know how. I need a GCF here and a GCF out of this. Biggest number coming out of 2 and 3 is just 1. X squared with 1x is going to have an x in common. Factor that out for x, and then 2x minus 3. Okay, I took 1x from here, and then I took this away as well. And I was left with 2x minus 3. Next up, I have 8 and 12. So what number can come out of those? 4 can. So I take the 4 out, and I have 8 divided by 4 as 2, 12 divided by 4, negative 3. You're almost there. You've almost done it. We've got what we want. The same binomial here and here. So I put the x plus 4 as one binomial, and then I just rewrite the 2x minus 3. Because this is when we took this, and we took this, and we kind of distributed it, right? Remember we would do that to get this step right here? We worked everything backwards. Now the whole time this equals 0 has been hanging around, and that's the last thing that we would have to do. All right. Oh boy, that didn't sound good. Hopefully it's okay. So we finish up with one more step. Let me get a brighter color here. And we want to do what we've been doing from the beginning. Take one binomial, set it equal to 0. Take the other binomial and set it equal to 0. Okay? It gives you 2 little tiny equations where if you want to go through the process of solving them, you can. One is going to be negative 4. The other one is going to be a 2-stepper where we end up dividing and getting x equal to 3 out of 2. Now,